Hi, in today's video we're going to take a look at this little lighting controller box. You've probably seen this in a previous video. I've had it running for many years, just running some sort of background lighting behind my computer desk, and in a few videos back I put together this PCB just to make things a bit neater for it, and unfortunately it's started malfunctioning. So we're going to have a quick look and see what's actually going on here. I have my suspicions, but we'll go into that in some more detail. Hopefully here you can see just a sort of quick video. Apologies for the poor camera work. The grainy videos because it's taken sort of later in the day. It's a bit dark, and I did just shoot it with my digital SLR camera, but hopefully you can get an idea as to how the thing is behaving. Certainly see some flickering. That is not the camera, that is actually happening on the lights themselves. And then at some point you should see where the thing just basically drops the power completely and will reboot itself. So like I said, we put together this PCB. If you're interested in getting some PCBs of your own like this, please do check out my sponsor PCBWay. PCBWay offer a high quality PCB manufacturing service with a simple ordering process and real-time quotes available online 24 hours a day. Their SMT service, including a stencil, is only $10 with non-framework, with a build time as little as 1 working day. Links are in the description below. Okay, so what I've done here is, because it's very difficult to try and work on this in the position it's in the living room, I've got here connected up. This one has popped out, but I've basically got the output of this little board that's running these lights. This is connected to, just going to have to rearrange things a bit so that we don't have these wires popping out every 2 seconds. But yes, this one here is just the output of the board itself, very precariously, he says, as all the wires pop off the other side, very precariously balanced together. I think that was the right order, but just so we can sort of try and mimic it on the desk here. So I'll try again to get those in, and might need to tape them down. Alright, they seem to be connected, so I've got some LED tape here, so hopefully if we turn this on, something should happen. I will drop the lighting down so we can see this in more detail. So here you can see the LED tape is running. I was going to do a sort of length matched section to what's behind the desk, but it doesn't seem to really matter too much on the length. It still behaves the same way, even if it's possibly, this is most likely a slightly longer run here. So you can see how it's going through the different colours, and this creates multiple effects when you've got it sort of along the back of the desk shining up at the wall. When you first turn it on like this, it will run like this reasonably okay for a while, but after a period of time it will start to flicker. So hopefully you can see there, as we're zoomed in, the flicker there, and like I say, this is not the camera. Hopefully the camera is picking it up. This is the actual LEDs themselves flickering. Now the little box that this is all housed in is basically, it's got the PCB, which has got a little Arduino board on it, Pro Mini I think, and it's got a voltage regulator. That's something that I did add when I put this PCB together that I didn't have before. I was previously just feeding the 12 volts input directly into the Arduino and allowing the internal regulators on that board to drop the power down. So I did add this 5 volt regulator, and that's the only thing I can think that's caused the problem. That adding that is possibly drawing a bit too much power from the tiny LED driver that's in this circuit. The LED driver in question is a 12 volts output, is maximum at 500 milliamps, rated at 6 watts. So the chances are that just adding, because this was running fine before, you can just see there how it sort of shut off slightly and then it's come back on. So yeah, I think that the reason is that the output is quite low on this, and when it was just going straight into the Arduino it was okay, and I think that basically now it's being pushed a bit too hard just with the extra current draw from the regulator, which in the previous video I didn't put a heatsink on it. It did get quite warm, but I still wasn't too convinced that it needed a heatsink. But what we would do is hook the scope up and see what's actually the problem. Is it that the regulator itself is getting too warm and then it's shutting off, or is it that the tiny little LED driver that's providing the 12 volts, that regulator, is actually dropping out itself? Okay, so the first thing I'm going to do here is just check the voltage coming out of that little mini LED driver. That's the item just down here, and it's a bit difficult to probe, but we should be able to get in there and see what we've got. The first thing we see is we've got 5 volts, and just get the probes the right way around and just do that again. So you can see we've got 5.8 volts, so that certainly is lower than the 12 volts that this is rated for giving out. So yes, we certainly don't have our 12 volt supply. Now I haven't actually got the LED tape powered at all at the moment, so the only thing in circuit is just the regulator, 5 volt regulator, and the Pro Mini Arduino board. So we can see there that for starters that the voltage is well below what it should be. Okay, so if we have a look at the scope here, we can see this is the waveform that's coming out of that little LED driver. We're at 2 volts per division, so 2.4, just above that, so we should be looking really to be sort of in the center line here, but we are just slightly below that, and we've got a bit of a nasty spike there as well. Most likely that's something caused by the switching effect of the transformer, and most likely because I believe what's happened here is this transformer has failed. This is the that's going to be an issue caused by the failing of the transformer. So what I'm going to do now is hook up the power again to the LEDs, and we will see what effect we get. So we certainly get a lot of whining from the transformer. It is squealing away. That sort of changes depending on what kind of LEDs are on, and what we're looking for here is for this waveform to drop off, which it should do, I suspect. If the regulator itself was dropping out, then what we should see is the incoming supply to the regulator, which is what we're looking at here, to be stable. Not glitchy like this, but certainly just to be a stable voltage. You can see here we are sort of dropping well below our sort of 5 volts that we had. So yeah, we're certainly, according to the scope anyway, we are looking down at it was changed a bit there, so we've gone to just blue LEDs only. Now it can take a little while for this to actually drop out, but normally it's pretty quick. Once it does it, then it will repeatedly do it every sort of 10 seconds or so, something like that. Well, we are back again, and this has been running like this now for about an hour, and it's making a complete mockery of me. When I first got the oscilloscope connected, it did its thing and dropped off perfectly, and I was like, brilliant, right, let's get the camera up, let's get set up, and let's get this captured. And nope, it quite simply is making a complete mockery of me. You can see there that the LEDs are working, flickering still, so we still know there's a problem there, and that's just the setup there. So yes, I'm not going to be able to get this to fail on demand on camera, which is just typical. But we know now that the LED driver itself is definitely causing an issue. It's squealing away like anything, and clearly we're not getting more than about 5.8 volts or so out of it, and that's without the LED tape being connected, so with no load at all apart from just the Arduino. So, safe to say, LED driver's dead, and I shall get a replacement. I think because this is such a low power one, I could possibly just try another one that's the same, because it does sort of fit into the case that I've sort of got designed here for this. So we could look at just replacing that driver with a new one, or possibly going for a slightly more uprated one. Maybe I could glue it on the back of the case or something. So I'll have to look into that and decide what I want to do. But for that video anyway, we've certainly shown that the LED driver appears to be the problem, and when it did drop out on me, it was dropping out the power from the actual driver was going, as opposed to the regulator just dropping out itself. So if you like that video, guys, please do give it a big thumbs up. Please subscribe if you're not already subscribed, and do consider becoming a Patreon and helping me to produce more videos like this for you. I'll see you soon in the next one. Cheers.